So I hope my screen is visible. Fine. So the technology democratization has led to make available the best features to be included in almost all products in a line, even in same cloud provider. Here, let's say Azure. Different products in data analytics. If you look into that, all of them would be looking alike when we just look on top of the features of each of them. In this session, let me share my learnings, how myself and my team analyzed different frameworks for our use case and chosen the right tech to solve our requirement. I hope it would help folks who are watching this to set up the best data architecture by choosing right tools for the right need. So Liji introduced me pretty much the same. So I'm Dinesh Kumar from Kispro, currently role playing as product manager for the analytics squad. And this is going to be my agenda. So as you see, I'll be covering so and so topics. First, I'll just talk about what databases, data warehouse, and data lake. And in this first section, I'm not going to talk very basic kind of thing. I'll just assume that the audience have a very basic knowledge of what database and data warehouse is. Not an advanced, but a very basic knowledge of what a database and data warehouse is. And next, I'll talk about Azure Synapse Analytics and Azure Databricks. And next, the important section, the common features which are present both in Azure Synapse Analytics and Azure Databricks, but it will be slightly different in each of them. And next, I'll talk about when we can use, for what and all scenarios, we can use Azure Synapse, and for what and all scenarios, we can use Azure Databricks. And next, I'll talk about my use case scenario at Kissflow, that is my analytics use case scenario at Kissflow, and what are all we did, and how we made a decision finally. And finally, what's next? Like after database, data warehouse, and data lake, what's going to come next? So, as I told earlier, the aim of my talk is to share my knowledge about understanding the difference between the tech stack, which look almost same in terms of features, but each one have its own ISP, right? Right. So this is crazy and slightly confusing time in data architecture space, I would say like that. More and more companies are shifting towards data lake, yet the traditional data warehouse and the database continues to provide value as it is. It was been there for decades. It has been rock tested for decades, and it's playing pretty well. Now, adding to that, we have this increasingly popular Lakehouse architecture and Delta Lake concept as well. The concepts I discuss here will be common that would fit for deciding over data services in Azure as well. What I mean is, I'm going to start talk about database, data warehouse, and data lake, but it's going to be common for Azure's database and Azure SQL data analytics and Azure Synapse Analytics and Azure Databricks as well. So, and looking at this, does both give the same feeling? When I just had my tiffin yesterday, I just had the same feeling. While just looking upon the database varieties in a cloud provider, and while I was trying to order a dosa in a hotel, I was just having the same mind. What is this? Everything is dosa, but each one has its own unique difference, right? So similarly, all are nothing but database, but each one will be having its own difference, its own special thing that can solve a special kind of problem, right? So first, let's just jump into the what is database. I would call in a very high level, what database is nothing but collocation of compute and storage, right? So all three of them are going to store data. That's fine, but I'm just talking about the architecture behind the database, right? So collocation of compute and storage. What I mean here is, it will be going to be one environment for both the storage and for the compute. The hardware resources will be on the same environment itself. The environment, in even in a simple example, let's take one CPU box. For storage, consider that the hard disk is present. For compute, consider that the RAM and the cores, all those are present, right? So in case, just imagine that your storage is not growing, but the compute is the request for compute is getting increased. Just imagine like that. What I mean is, more and more requests are being submitted to the database to process the data and return the result. Like that, more and more requests are coming that database is not able to handle. In that case, only option is to scale that server only, right? You can add one more node, right? You cannot just scale that compute power alone beyond an extent. We can change the compute power. Let's say a 4 GB RAM to 8 GB RAM. I'm not talking about that small scale. I'm talking about a bigger scale, right? That's why when it comes to database, you cannot find or you cannot see as a structure which is of more kind of more number of nodes in a database kind of architecture, right? So, and the database is nothing but schema on write, right? We all know what a schema is. Schema is nothing but the skeleton upon which the data is being stored and retrieved, right? So while you are using a database, before you insert a data into the database, you will be having that schema ready, right? Schema, here I mean the table. You would have already created that particular table, that particular column, the particular data type, the particular foreign key, primary key relationship. Everything will be there. After the schema has been set, only then you will be writing, right? So in a single word, we can term that database is nothing but schema on write. These terminologies will be little bit odd, but or difficult to understand. But upon while I start discuss about data warehouse and data lake, it will be the comparison would be easier. And in my perspective, I would recommend database when you are having the data in a very structured format, like rows and columns. You are clearly having your data as rows and columns, and the data size is less than terabyte. What I mean is, from now, after 2 years, the data size won't grow. After 2 years or 5 years, the data size won't grow beyond a terabyte. Means you can definitely choose a database, right? Size is not an issue as per a database document. Even if you go and check out Microsoft SQL Server's database size, it will be telling a huge value, not even a TB, but it will be telling a huge value. But I mean here, I mean here for the compute power also. Not, you're not just going to store the data, but you're going to compute it as well, right? So keep both of them in mind. And one more purpose which I would recommend is, choose a database if your purpose is for OLTP, that is online and hello, hello. Okay, I hope my voice is clear. And so when your purpose is purely for the transaction basis, right? It's not for analytics, but for the transaction basis. Even in this case, you can argue that the same typical database like a SQL Server or PostgreSQL, which is being used for the basic analysis as well, right? Yes, it is being used, but what I mean is, in all those cases. So coming back, uh, I just told that if you just choose a database only to solve the purpose of OLTP, not OLAP, right? OLTP is nothing but transaction processing, uh, the primary purpose of an application. OLAP is nothing but the primary purpose would be analytics, right? So even you can play the analytics on top of a database like SQL Server, PostgreSQL, or MySQL. I totally agree that, but the scenario is, you will not before playing analytics with a very planned structure, you will be creating cubes on top of the database, right? On top of that only, you'll be creating analytics. sorry, you will be playing with analytics. So just don't mess with both playing with the database for both OLTP and OLTP. Choose a database that could solve the purpose only for OLTP alone, right? And next is, I would not recommend a database to be allowed to play for ad hoc analytics. I just told a bit more earlier that ad hoc analytics is nothing but without any plan or without any pre-planned structure on the database, uh, structure created on the database, playing analytics. That is, without any cube or anything on top of a database. If you just play analytics over there, if you just place a SQL query with multiple group bys and what to say, multiple aggregations and all those things, the total compute power will be consumed by the analytics workload itself. The database will not be able to solve the primary purpose of OLTP, right? So I don't recommend if you are playing ad hoc analytics on top of a database. And next, when you have more dependency in sharding comes into picture when when a scenario occurs like your table would have been grown to a great extent, and you cannot have the table as a single table. You would be needing to separate the table into more than one, and you will be sharding it into different servers, right? It is possible, yes, it is possible in database, but it cannot be scaled beyond a limit, right? So if you're pretty sure that sharding would be needed at a later point of time, let's say 2 years or so, at the initial time itself, better don't choose a database. And when we just talk about database itself, it it would involve a vast number of topics, right? Database is nothing but a common topic. Under that itself, we have relational databases and NoSQL databases, right? I didn't dive into much on the previous slide, and even I'm not sure I'll be able to cover all the topics. But for a high level picture, I just added this slide. Every company will be having different storage models, right? They would be having relational tables also. They will be having graph kind of graph mode of tables also. They will be having document oriented tables also. Each company would be having different varieties of data storage models. In that, as you see in the statistics, relational tables rank higher, right? Most of the companies, most of the data are nothing but relational kind of data only. That is rows and columns, typical rows and columns, a matrix kind of data. The other kind formats of data are nothing but graph data format, key value data format, document oriented, and column oriented. Each of them solve a different purpose. For example, if you have a scenario in your application design that the schema of a table will not be same, the schema would be changing frequently, or at the application end, the control on schema will not be having at the application end, then the best choice would be going with document oriented database. And also it solves the document oriented database solves another purpose. When you have a scenario to store subtables into main tables, right? For example, in Jira, you would be creating a main task, and you'd be able to add subtask and all, right? That's a very generalized example, but just imagine that you have a main table. Within that main table itself, you might have scenarios like you need to add subtables, right? In these two scenarios, that is frequent schema changes and the need of subtables, in either case, the best scenario would be to choose the document oriented database. And one best example for document oriented database is MongoDB, right? Similarly, if you take a column oriented database, there are different options like Apache HBase, Apache Cassandra, and many more. Similarly, for key value database, there are many options in each cloud provider. And when you take a graph database, it is nothing but Neo4j. Mostly graph database is being used in terms where you would be needing to connect different entities with one another, where you would be having many to many relationship between the entities. For example, if you take Facebook, it is nothing but it's having a graph database as one of its database at its backend, because friend of Dinesh would be friend of Amal, friend of Amal would be friend of Anbu, friend of Anbu would be friend of Liji, and friend of Liji would be friend of can be suggested to friend of Dinesh. Like that, all these would be linked as an entity, right? So for such a kind of scenarios, graph database would be okay. And I guess I cannot go further further go in detail, because the keeping the primary agenda of the meeting, I'll just proceed to the next slide. So after database, now let's see about the data warehouse. I hope you remember the first point which I told in database, co-location of compute and storage. That is nothing but the database. When it comes to data warehouse, it's nothing but the separation of compute and storage. The problem statement of database, which I spoke in terms of compute, has been addressed in data warehouse, right? Here, the storage will be separated and the compute will be separate, right? If you want to scale the storage alone, you can independently scale the memory size of storage, whereas if you want to scale the compute alone, you can independently increase the compute power without affecting the storage, right? So like that, you can independently scale either storage or compute. That's the primary primary ISP of a data warehouse tech stack. And coming to next, it's again the same schema on right? I just explained this schema on for the database itself. The point is same. Before you store a data into a data warehouse, you have the table created in the data warehouse, and you'll be writing on top of it. Right? The primary difference of database and data warehouse is the separation of compute and storage. Okay, and where I would recommend data warehouse is if you know the metadata and schema, right? And the format of analytics to be done, to be played, right? I definitely prefer data warehouse. And if you are pretty sure that ML or machine learning or artificial intelligence kind of workloads, GPU workloads are not going to be played much for a couple of years or 5 years or 10 years, then definitely you can choose with data warehouse. And one more main scenario is there could be situations where uh, you would need to expose your data to the out of your data stack, which can be which you will provision and give the access to your customers to play analytics on top of it, right? Very simply, let's take some example like Uber. Okay, so Uber has data, but it also just take a simple example that it is exposing some portion of its data where the end customers or who are the tech company, they can connect to the data system and play analytics on top of it, but they should not tamper within the data architecture of Uber. In that case, data warehouse plays a vital role, because when it is data warehouse, you need not worry about setting up the initial infra, because once you expose it to customers, you will definitely not know how much customers would be playing the analytics, what kind of workloads, on all those things, right? And when you expose it as a data warehouse, you'll be having the control to increase the compute when a huge request arise. Similarly, you can decrease the compute when the requests are getting reduced, right? And also the complete secure what to say, a better security architecture is being present within the data warehouse to address such a need, exposing out and allowing customers to analyze. And when you see here in this diagram, the another main point where within data warehouse is the data will be converted to proprietary software's format, right? Let's take an example. Either it could be Azure Synapse Analytics or Google BigQuery or Snowflake, whatever the data warehouse may be. From From the source systems, when the data is being injected into a data warehouse, the respective vendor will convert that particular data into their own proprietary format, right? The format which I mean is for files, we are naming formats like CSV, TSV, TXT, right? Within the database also, there are specific formats like ORC, Parquet, and all kind of formats. ORC, Parquet, and all open source, but if it goes to within the vendor's data warehouse, they will compute it, they will convert it into their own data format, and they will store it in that format only. Only while you come out of this data warehouse, only when you decide that okay, I don't want this data warehouse, let me decide to come out, they'll export the data into a different format like ORC or Parquet and provide the data to us. That too based on the conditions and the way of agreement we put while we initially go on with the data warehouse, right? So as you could see, from the data warehouse itself, the BI users can directly access and play analytics on top of it, or from on top of data warehouse, the cubes can be created, and on top of cubes, again, the BI users can play the analytics on top of it. And then I would not recommend a data warehouses. Uh, when you have the data like image and video, obviously you will not choose data warehouse, but I just added it as a point here, because even to store that kind of data, image and that kind of data, all the data warehouse will be having a data type called binary, like integer, string, varchar. There is a data type called binary. Using that, within that binary type, you will be able to store any kind of data, either it be image or store video. But it is generally not recommended, right? And one more thing, I didn't specify about the size at all, right? If it is going to be a structured format and you know the metadata and schema, you need not worry about the size of data at all. It can go beyond 10 TB or 20 TB or 50 TB. No worries at all. The data warehouse will take care. And let's jump into the next thing, data lake. In this case, the difference is separation of compute and data, right? So when you see the data warehouse, I just told that data warehouse has addressed the problem of database by separating the compute. But again, here there is a problem that vendor will be converting the actual data into their own proprietary format and storing that, right? That particular problem will be addressed in data lake. Again, in the data lake, the compute is going to be separate. You can scale the compute as and when needed. Uh, but the advantage is the data will be as it is from the source system. In what kind of format you are going to send it into the data lake, it will be in the same format. There will be no vendor lock-in or no conversion at all. So behind the screen, you are saving the conversion cost also, right? Even it is vendor's proprietary format, a specific conversion has to be done, only then the storage happens. But here it is not happening. It's getting stored directly, right? And the next main difference on data lake is schema on read, right? Both data warehouse and database, it's about it's having their methodology as schema on write, but when it comes to data lake, it's having the paradigm as schema on read. That is, the data will be stored as it is from the source system. The data will be stored into the data lake as it is. Either it could be in CSV or TSV files. Only while reading, such services will be creating the schema at this layer. Okay. Let me tell a simple example. Let's consider that there is a 1 terabyte of CSV files. Each file where the table is having where the CSV is having 100 columns, right? The data scientist, all 100 columns are not needed. So what they'll do is they'll create a Spark service, they'll create a schema, and they'll choose only 50 columns what they needed, and they'll create a different table over here, and they'll do all the advanced analytics like predictive analytics and machine learning, all those kind of stuff. And similarly, when it comes to BI users, again, they don't need all those 100 columns. They will again choose a 40 column or 30 column, whichever they need. They'll create a schema, separate schema in this query engine, and they'll create a table, and they'll connect it with BA tool and play and do analysis, right? So actually, the source of truth, the data source of truth is having 100 columns. The data scientist will be choosing 50 columns and working on it, whereas the BA users will be choosing the same 50 or different 30 or different 40 columns, and they'll be working on it. That all these three will be separate thing. There will be no kind of merging or uh, no no overlap at all, right? And when I recommend to choose a data lake is, if your system is producing all types of data of any size, all types of data, I mean text format, table format, semi-structured like XML, JSON, unstructured like image or video, like this, all formats of data is being produced. The two, you will not be able to predict size at all, right? In that case, you can directly choose data lake. And when you have a scenario like you just need to store the data now and you don't have a plan about running any analysis on top of it, right? Let me tell a simple example. Let's take Swiggy app. While they were very small company, the team was very niche and very small, and they didn't have separate team for application analytics and all those things. So, but what they did is they injected the data to a data lake kind of architecture, and the data is being stored uh, from the day one itself. But there was no analysis at all, right? But there was no analytics run on the data. But at a later time, after a couple of years, when they got a great revenue and all those things, they were able to create a separate team, and they were able to play the analytics on top of the data, right? So again, the third point is also going to be the similar explanation only. Data lake would be often chosen in many cases when there is internal analytics need, right? Where you will be dumping all the data, but you'll be playing on the data as and when you need at a later time, at any time, right? So this is what the recommendation would be. And I would recommend data lake again, the same point in another format. I'm going to say, when when you are going to need the data to be ready for analysis immediately, and the users which I mean the business users or BI users who doesn't know to write code, they need to play on the data and take reports on it, right? In that case, I don't recommend data lake. So once again, to summarize, there won't be any conversion or copying to another system. The data relies in one single place, and all the external systems access over the same data. So that's a good point about data lake in my point of view. And after all this discussion, you'll be having this in mind. Why so much of different types of database exist? Database, data warehouse, data lake. Why so much of types of categories exist, right? Because each type solves different problem statements, right? That's what the first point I told in the while I was introducing itself. And one more thing is, when NoSQL came into the picture 2 decades ago, people started to talk that RDBMS will be dying soon. Similarly, when the big data talk was at its peak a decade ago, 10 years back, general talk was that okay, the whole database DBMS architecture is going to die. Big data is all, big data is future, and all those things, right? But what happened? Still, RDBMS rocks even now and will rock in the future too. I can be sure of that. This argument will be similar, something similar to the application development people also. They'll be talking that when the microservices architecture came, okay, that's it. The monolith architecture is died out. All the applications are going to be microservices, right? So, but it's not going to be the case. Even now, or even in future, people have agreed that monolith architecture would play a vital role for the application development. So let's jump into the next section to talk about Azure Synapse Analytics and Azure Databricks. A quick time check. Okay, I have 25 minutes. Okay. So let me just quickly give an overview about these two, what it does, and I'll just talk about the common features between these two services, these two products, and even though it is common, how it is different, right? So Azure Synapse Analytics is nothing but Azure SQL Warehouse rebranded. Even though it is rebranded, there is a lot of background engineering architecture changes were done so that it plays so good on the level of performance when it's being compared with the other competitors in the same line, right? And apart from that, Azure SQL Warehouse version 2, Azure Synapse Analytics version 2 is nothing but providing Azure Synapse Studio, right? So the Azure Synapse Studio is nothing but a development environment where the whole data team would be sitting together, would be using it for to solve all kind of purpose they would need. For example, as you could see in this diagram, the raw data will be stored into data lake, right? So using this Synapse Studio, you can easily provision a data lake, manage a data lake, or maintain a data lake. And after that, you will be cleaning the data. The cleaning is can be done by the orchestration module that is nothing but the data factory, which is being embedded into the Azure Synapse Studio. And then you will be running standard reports, right? Standard reports, I mean, quick kind of analysis or quick kind of reports. Once the clean data is available, you will be able to write SQL queries or Python scripts, and you will be able to do quick analysis or find insights. And on top of that, you'll be able to produce ad hoc reports. Now here comes the Power BI. Power BI is again, it's embedded into Azure Synapse Studio, where using the Power BI, you can play ad hoc reports as well. And while you're creating report on terabytes of data, you don't need to worry about the compute at all. You'll be able to provision two types of compute infrastructure within Synapse, that is provision and on demand. Provision is nothing but pre-planned compute architecture such that so and so RAM capacity, so and so number of cores, and on top of that, the analysis can be done. And on demand is nothing but you don't need to worry at all. Once you submit the query or do the drag and drop in Power BI, immediately the background infrastructure, background hardware will be provisioned, and you will be getting the results. And all beyond that is nothing but predictive analytics, prescriptive analytics, and data exploration. For all those things, you have Apache Spark included within Azure Synapse Studio, and you can write Python scripts, Python or Jupyter notebooks, and you can do all kind of such futuristic analytics. So now coming to the Databricks, it's nothing but one of the tool for data lake in a very lame term. But basically, it is nothing but a hosted Spark environment, which is getting expanded with Delta Lake format, ML flow, and SQL analytics. When I say hosted Spark environment, it is nothing but you don't need to worry about creating hardware, installing Spark on it, planning about the number of executors, number of drivers, and all those things. It will be on a couple of button clicks, your Spark environment will be hosted, and you can start playing with it. And when it comes to Delta Lake, I'll talk in the next slide. It is nothing but a new data format, right? And ML flow is nothing but we call what to say? We call the application rollout cycle as a DevOps, right? Similarly, machine learning model has to be created, it has to be tested, it has to be retested, and it has to be productionized, and it has to be again changed, it has to be tested, it has to be productionized. Like the cycle is there, right? So this cycle is being called as ML flow. There are a lot of tools are coming in, and ML flow is an open source tool that is being available in Databricks, right? And SQL Analytics, as you all know, just playing on top of your data, doing some SQL queries and getting some insights. And the best option to choose for Azure Databricks is simply say, if you have a lot of machine learning workloads, but you don't have the knowledge of Python, or what to say, not to say Python, or you don't your expertise is not beyond Microsoft, then you can directly go with Azure Databricks. And within Azure Databricks, you have a well-tested ODBC library and well-glued Azure Data Lake kind of libraries where you'll feel comfortable, right? That's what I come to say. When you decide to choose Data Lake and your Microsoft guy, you can directly first try out Azure Databricks. I'm sure you definitely find it comfortable. And in simple words, the data engineers will be able to build the data pipelines. The data scientists will be able to train and deploy the machine learning models. The data analysts will be able to do the ad hoc analysis via Python scripts. Coming to the Delta Lake is nothing but another layer that sits on top of your data lake to provide the asset transactions, right? So asset transactions is a primary functionality of a database. So this, when you store the data in this format, you will be having the advantage of data lake and also database as well. That's what the main purpose of creating this. And also it unifies the streaming and batch processing as well, and it is fully Delta Lake is fully compatible with the Spark APIs itself. So it's not that you need to learn another a set of APIs to play with Delta Lake. It's all enough you know about Spark and Spark APIs. You can easily play with the Delta Lake as well. In simple words, it's about saving data in a format called Delta. The data will be saved in a Delta format, and you will be playing on top of it. So next, another important section: what are all common features in Synapse, but slightly different. So both in the first column is nothing but the feature that will be present in both in Synapse and Azure Databricks. And within the second column and third column, I would have mentioned what is the difference factor in respective thing. Okay, so when it comes to both Synapse and Databricks, both have Apache Spark, and in both you can play with Delta Lake format. But the difference is Azure Synapse Analytics is using the open source Spark, whereas the Azure Databricks is using the latest stable version which the Databricks has rolled out, because behind the screen Spark is being contributed by the creator of Spark itself is Databricks only. They only launched it as launched the Spark as open source. So there will be always what to say, the patch fixes or a feature getting introduced. It will be a kind of latest when it comes to Databricks than Synapse. And when it comes to Jupyter notebooks, Azure Synapse Analytics is using Interact notebooks, whereas Azure Databricks is using Databricks notebooks itself with additional features like real-time co-authoring and automated versioning. Real-time co-authoring is nothing but simply say, if I open a Microsoft Word document, another person also can open the same document. Simultaneously, my changes will be visible to that person, and his person's changes will be visible to me, right? So that's what I call real-time co-authoring. Both of us can see. And automated versioning. The versioning happens for every change that I make, or every save I make on a Jupyter notebook. So I can always easily backtrack to a previous version when something is not fine. And when it comes to accessing data from a data lake, in both Synapse and Databricks, you can access data, but here the difference is in terms of usability. When it comes to Azure Synapse, it will be easier to query SQL scripts, right? SQL scripts and notebooks. The file will be there on a simple right click. you can easily deploy, you can easily write SQL scripts and or even Python or a Jupyter notebook. But when it comes to Azure Databricks, you would need to mount the data lake into that particular notebook, and then you need to start the write the query. So a slight usability difference, but anytime this might go away, because since it is a usability difference, the product team might decide to do the feature more easy for the developer. And when it comes to cloud-hosted Python and SQL environment, I would recommend Azure Synapse Analytics is good, can be go on for ad hoc analytics, because the Power BI is embedded into Azure Synapse Analytics as well, right? Any business user can also play and get insights about the data. When it comes to machine learning model creation, configuration, and deployment, I'll go suggest to go for Azure Databricks, right? So, and the last thing is compute separate architecture. Both have the compute separate architecture. There is a slight difference, and they call it differently: SQL on-demand pool and auto-scaling pool. Auto-scaling pool is nothing but you'll be creating a cluster. You'll be telling the cluster that see, this is the minimum node and this is the maximum node. Don't go beyond maximum, or don't go very less to the minimum. Just play within that kind of infra. When it comes to SQL on-demand pool, you don't need to worry about the infra at all. Based on the query getting submitted, the infra will be automatically scaling up. So that's about the common features in Synapse and Databricks. And I just framed 7 scenarios where where as a person, I just think about the scenario and whichever would be preferable. As I told earlier, ad hoc data lake discovery by code, if this is your need, you can directly choose both Synapse and Databricks, because both support Python, both have the Jupyter notebooks, and using that you can directly play with the data lake's data and do ad hoc analysis. And when it comes to SQL analysis and data warehousing kind of need, I definitely recommend Synapse, because when it comes to data warehousing kind of need, Synapse is first, data lake is next. When it comes to data lake kind of need, data lake is first, Synapse is second. Like that, you can simply rank. And if it is for self-service BI, business users will be creating the reports. I definitely recommend Synapse. And if the scenario is something like it's going to be the same data, on top of the same data, the data scientist would be playing with Spark, and the data analyst would be playing with SQL, and the business intelligence people will be using the Power BI. Definitely, I recommend Synapse, right? So coming to the other side of the scenario, when it is of more of machine learning and artificial kind of intelligence kind of requirement and development, and if it is involving more GPU intensive tasks, I prefer to go for Databricks. And if the dependent tech is much on Delta Lake format or Apache Spark, the preference would be can be made on Databricks. And I think I have told the reason already. And the 7th point would be smaller, but the developers know the importance of it. If you prefer that the Git-based developer experience should be inbuilt, then go on for Databricks, because this particular feature is not yet fully supported in Synapse. So I just spoke about completely siloed kind of thing. When to use data warehouse alone, when to use data lake alone, right? But in general, a common scenario would be that in enterprises, both data lake would be used and data warehouses will be used, and it will be coined in a single overall data architecture. So those specific scenarios would be the data sources would be producing any kind of data, and all those data is nothing but called as raw data, and that will be converted to what to say, confirmed data means you can mean it as cleaned or partially cleaned data, right? And on top of that, you'll be cleanly pulling out only the extracted things, and you'll be mostly having the structured data alone. So that is nothing but this particular layer. And finally, you'll be using that particular structured data to create models or to do analysis and all those things. So in total, if you see, the first two part would be around data lake, and the second two part would be around data warehouse. So in a typical enterprise world, they would be having both data lake and data warehouse architecture, where the specific teams would be utilizing what they need. So and next, let me just tell my use case at Kissflow and how we addressed the advanced analytics need apart from the general reporting which we already had. So the use case, just to start with it, let me tell a few words about Kissflow as well. Kissflow is a pure SaaS product that is completely cloud managed. Okay, and it is a completely no-code product where the business users will be able to develop workflow apps by themselves. That for the OLTP, for the applications database, we are using MongoDB, and that is being hosted in Atlas. For the data isolation, we have isolated such that one database will be separately created per customer, right? And even before MongoDB, it was MySQL. And the reason for switching, I have already told that in the very beginning of the slide. We had the problem of schema changing, because since the business users will be creating workflow applications by themselves, the schema would be control on schema will not be with us. The schema would be changing frequently, so we decided to go with MongoDB. And each customer will be having their own schema. As I told earlier, since each customer would be creating their own applications by themselves, each customer would be having their own schema, right? So there is nothing like a common data model at all. So another important point is, based on our product nature, per customer data won't be very huge. We have 10,000 plus customers, but 10,000 plus customers will be having individual database for each of them. So if you accumulate all the 10,000 customers, the data size will be huge. But if you just take one customer separately, the data size will not be so huge, right? So another thing is, the basic reports what we provided earlier is being run on top of MongoDB itself, right? And we faced all the problems which I mentioned earlier. When there was heavy load on reports, the actual application would go down, and we will be scaling the database like that. We were facing all those problems, and there is no separate analytics database as of now. Having all these in this mind, we just started analyzing different options, whether we should go for data lake database, go back for database, or we should go for a data warehouse. And we did separate POCs for each of them. For example, when it came to data lake, we created a data lake in Azure Data Lake Storage. We dumped all the data in it and created a query engine on top of it. And on top of that, we created an ODBC library, and using that library, we allowed the BI tools to be connected. But it was not much user friendly, and the concurrency also, we faced a lot of issues, and the query retrieval also was not so fast, because as I told earlier, the per customer data will be not very huge, and data is not for small customers, right? Okay. So it's for big data kind of architecture. So we just skipped on that, and we were sure that the database would not be suiting our need. And finally, we chosen to go with data warehouse, considering all the points which I told earlier. We justified all those points, and we decided to go on with data warehouse. So what next? I'll quickly walk through in a couple of minutes, considering the time. Okay, we have 7 more minutes. Okay, so we have database, we have data warehouse, and data lake. So what's next? It's the new paradigm called data lakehouse. It's not a separate technology, but any set of products combined together, you can call that as a data lakehouse architecture. Okay, so the end goal is, to string together the best of both worlds, that is data warehouse and data lake. Both have specific advantage and disadvantage. Data lakehouse will be stringing together and it will give all the benefits of both the systems. It will be implementing the data warehouses, data structure pattern behind the architecture, and data lakes management features on top of that, right? So finally, a typical structure would be there will be single data lakehouse for structured, semi-structured, and unstructured data. On top of that, it would act as a multi-solution system where the data scientist and the data analyst would be able to play on top of that. And the data governance would be very easy because it is going to be single system. And again, since it is a single system, it would be cost effective too. Again, I would strongly tell that based on your requirement, you should be checking that whether you really need data lakehouse or it's enough to go with data warehouse or data lake, right? So this is a diagram from Azure Databricks. So I just pointed here. So when it comes to data warehouse, the external data will be ETL'd and it will be moved into data marts. On top of the data marts, BA tools and report tools would be doing the analysis. And when it comes to data lake, the structured, semi-structured, and unstructured format will be placed on the data lake, and separate ETL and the data preparations will be done separately by the data scientist team and the data analytics team, and the insights will be derived. Similarly, when it comes to data lakehouse, the pattern would be same, but behind the screen it's going to be the same pattern, and there will not be any dedicated or separate ETL or a data preparation or data validation. It will be on the same what to say analytics engine. On top of that, both the data analytics team and the data analysis team can play and derive insights. So these are some useful links we went into, and I just ranked the top 5 links whichever made useful for me. And obviously, I'll share the slides as well, so you can refer it to. So finally, just think that the end goal of your data architecture should be to allow the users to take smart decisions. It's all going to be that only, right? If user wins, we are also winning. And one more thing is, architect such that the copying of data gets lesser across the teams, because once the copying happens, then each team would be having different versions of data, and the insights each team would be deriving would be different, obviously. Just see here, from the data lake, the copy happens to the data warehouse first, and from the data warehouse, the copy happens to multiple teams. The BA team would be creating cubes, and the data science team would be exporting it as a local file and save it within their local mission, and there will be multiple copies, right? So it would what to say, it would affect the decision making, because different copies of data would produce different insights, similar which could result in different decisions, right? And always define your goal based on customers need. Don't always jump into that, okay, we should provide ML, or it's going to be ML, or kind of thing. Still, many products, many use cases doesn't require ML at all, right? So always define your goal based on customers need. Before ending, I just keep this point in mind. Don't choose a data take just because you or your team knew it. Simply say, if you are familiarized with a data warehouse, then just don't decide that you need to choose data warehouse. Again, explore all other options and decide the best of it. And don't if you are going to link your app with the wrong database, then this is what is going to happen. I think these soap and the hand sanitizer is the one we are yeah, hand wash is one we are using pretty much in our lifetime, but in the past 2 years we have been using very much. So I thought this would be a very good example to place here and place this as a meme here. So if you link your app with the wrong database, this is what happened. The data would be there, and the app would be accessing, but there will be no result at all coming out, right? So that's just a simple example. And all the best for choosing the right database for your need. So thanks a lot.